Yeah, I believe the whole class is discussing during the final. I have no problem with that. But at least you cannot compare your answer from one to the other. Okay, everyone has to look after themselves. It's not, can you try my constant and see whether it will work? That's not work like that. Okay, it's like a sinking ship, right? You wear your own life jacket. You're not going to give your life jacket to another friend. So my general view regarding all this is proctoring is a freaking waste of time. Okay, there are ways that we can test you that we don't need proctoring. Okay, so this is how you'll be tested. Okay, so let's look at the content. Anyone, any questions so far? Anyone, please. You can talk to me also, okay? Don't just type, okay? Anyone, any question, please?
You're too tired to be talking.
Say it again.
I'm a little too tired to be talking. I want
Oh,
to
okay.
sleep.
Okay, good morning.
Good
Okay,
morning.
go and smoke something, make you high first, then come back.
And that doesn't work for me. That'll make me more
Okay.
sleepy.
Or,
That'll make me
or,
more sleepy.
or drink coffee, okay? Drink plenty of coffee, okay?
Yeah.
Any anyone, any other question so far? No? Okay, so let's look at the content. Okay, so what we'll be doing, what the content we'll be learning is we are going to learn stress strain. I do apologize, my house is a bit noisy because my neighbor is renovating his house, and where I'm living, the houses are very close to one another, okay? So we're going to learn about stress and strain under axial loading. Okay, so this will take about 2 weeks to complete, right? Then we'll look at shearing stress. So this will take about another 2 weeks to complete. Then we go into bending stress or bending moments. So this will take about another 2 weeks, and then we'll look into uh, design and analysis of beams. So this is another 2 weeks. Okay, and then we have one more, which is Mohs circle or combined loading. Okay, so this will take about 1 week, and then the last one will be 2D and 3D Mohs circle. So this will take about 1 week. Okay, and then your term test. So then we have term test. So the term test will take about 2 weeks. Okay. So if you add them down, 2, 4, 6, 8, 10, 12. Okay. So 12 weeks gone. Okay. So this is the content that will be going for. Okay. Anyone, any questions so far? Okay. No. If not, this is our course outline and information. Okay. So again, I'm going to ask, are you all satisfied with this? Anyone?
Seems fair to me.
Yes?
Yep.
Well, when are we having the term test 1 and term test 2? I don't know yet. I need to plan. Probably I'll let you guys know by the end or before next week lecture. Okay. Anyone else? Any question? Okay, so your test, okay, the test will be done on crop mark. Okay. So I will practice with your quiz also. The quiz will also be on crop mark. Okay, I'll practice with you guys. So crop mark is a software that we use. Okay, so I want you all to get used to it. Okay, not too much of a surprise for you guys. Okay, I'm thinking about the term test now. So another thing I could do is 40%, and this is 25 and 25. Hold on, I'm not done yet. So this one will be your highest grade. Okay, and these two will be your lowest grade. What do you think? Anyone? Is this okay? 30, 30, 30 is better. Anyone else? 30, 30, 30 is better. Okay, then I'll ignore this one. Okay, so I'll ignore this one. I heard final exam was hard. Don't listen to what you hear. Okay, in the final exam last term, I have students scoring 95. Okay, I also have students doing badly, getting 20. Okay, so how easy or how tough, it all depends on how hard you work and how much you practice. Okay, so don't hear from other students, oh, I heard that the final exam is really hard. Okay, then in that case, I'll cancel this one. Okay, so it's 30, 30, 30. Okay, any questions so far, please? Anyone?
Nope.
Nope. Okay, good. Right, so we're going to start
Sir,
now.
I have a question.
Yes.
So a friend of mine is trying to connect to this Microsoft Teams meeting, but he is not able to. Could you add him in, please?
Can you type in his last name, please, or his full name?
Can I type in his email address as well?
Yeah.
Okay.
So I'm going to. I'm still here. Okay. I just need to add him. I do apologize for this. It's okay. We still have a bit of time. I'm not seeing his name on the message.
Yes, sir. I'm just typing it in. Yeah.
Okay. Dara 4. Okay, hold on. I see him. So it's Dara4 at mcmaster.ca.
Yeah, I just.
Okay, he's in already.
Okay, thank you, sir.
Thank you so much for letting me know you're a good friend. Let me know if Dara4 is here, okay? If Dara4 is not here, let me know. Right. So now we are going to go. So we are going to look into stress strain. Strain under axial loading. Okay. So this. So if you were to look at the textbook, right? This is chapter 2 of your textbook. Okay, it's on chapter 2. So we are just going to look at axial loading. Okay, so focus on this. Loading condition is only axial. Okay, so what this means is if we have a structure Okay, so this is our structure. Right, and then on our structure, we have our centroid. So this line I've drawn, this is our centroid. And on our centroid, we have a load. Okay, we have a load now applying exactly along the centroid. Okay, so this is our load. P is, so the load is applied along the centroid. Okay. So under this configuration, okay, so under the shown configuration, right, the structure is under under axial loading condition. Okay, so whatever I teach here will only be possible, okay, if the load P is applied along the what? The next important thing to look for is applied along the centroid. Okay, so there are two ways that we can design our structure. Okay, so there are two ways. Before we talk about two ways to design our structure, right? So when you look at this, right, structure. No, let me think. Should I mention there are two ways first? Okay, I'll mention. So there are two ways. Two methods to design structures. Okay, two ways. So the structure. So one way. So method number one is based on reaction force. Right, and then method number two. Right, method number two. Right, method number two is based on elastic deformation. Right, so what I'm going to teach down here is, does not mean you only need to use method number one. Okay, you can combine both method number one and two. Okay, so you can combine both methods number one and two to carry out structure analysis. Right, so method number one, let's recall method number one is really straightforward. You guys are really familiar. You guys have done your static and dynamics. Okay, so method number one is based on reaction force. So what do I mean by reaction force? So I'm going to do the next page. Okay, so are you guys copying? You all need some time, or we are okay? If you need some time to copy, I'll stay on for another 10 seconds. Okay.
Could you go back up a little bit?
Yes. Is this okay?
Yeah, that works. Thanks.
Thank you.
So you'd be posting these notes, right?
Oh yeah, of course, definitely. Okay.
Yeah.
And your end, don't just watch the screen. Okay, I'll fall asleep if I just watch the screen. Okay. Copy something, write something. Unfortunately, it's Saturday. You cannot watch the stock market and listen to my lecture at the same time. Okay.